This video will focus on two-step equations. We will do a series of examples together from this page, and then I will expect you to complete the rest of the page on your own for practice. So you want to be taking notes as I'm showing you how to complete the problem. We're going to begin with number 1. Keep in mind as we do these problems that I will show you a method to complete the problem, but it's not necessarily the only way to complete it. As I solve equations, this is the simplest way that I found to complete the process, but there are other ways. So let's start with number 1, and I would like you to put a rectangle around the a and the 4. The point is to isolate a. So the first step I'm going to take in trying to get a all on its own is to subtract 2 from each side. When you look at it, I have two problem numbers. So if I separate this into the right side and the left side, on the right side is where my variable is, and my two problem numbers would be 4 and 2 because they're also on the right side. And on the right side, I should only have the variable a. I need a to be alone. So the first step here is I'm just taking this 2 and I'm basically getting rid of it on that side. Whatever you do to one side, you have to do to the other to maintain equality. 6 minus 2, I get 4. I carry down the equal sign, I carry down the a divided by 4, and 2 minus 2 is 0, so that's gone. Again, I'm trying to isolate the a, so I'm going to put a box around the a. The box I placed to remind myself that I'm not moving that piece is staying put, and I'm getting rid of the other portion. A and 4 I separated by division, so the inverse operation is multiplication. So I multiply this side by 4, and I also multiply the left side by 4. 4 times 4 is equal to 16. And then on the right side, I get 4a in the numerator, and I get 4 in the denominator, because 4 times 1 gives me 4. 4 over 4 equals 1, so I'm left with 1a equals 16, or you could say a equals 16. So I found my solution. Let me show you another method that you could use to do the same thing that we just did. It's just a different order. So instead of subtracting the 2 first, what I could do is I could say, all right, I know that a is separated from the 4 by division, so the inverse operation is multiplication. The reason why I don't do this first is because it's more complicated. If I multiply the right side by 4, I have to multiply the a divided by 4 and the 2 by 4. But as long as you do the same thing to both sides, it's still legal. So I can still do this. It just looks a little bit more complicated. So I take the 4 and I need to multiply it by the a divided by 4. I also need to multiply the 4 by the 2. So I'm using the distributive property. I get 4a divided by 4 plus 8. Well, 4 divided by 4 equals 1, so I get 24 equals 1a plus 8, and then I subtract 8 from each side, and I'm left with 16 equals a. So it's two different ways to complete the same problem. You can do it either way. I will normally do it the first way that I showed you, because I think it takes less work, less writing. Let's move on to the next problem that we're going to do, which is number 3. All right, so 9x minus 7 is equal to negative 7. I'm going to put a box around the 9x because I'm trying to get that x alone. So the first problem number I'm going to get rid of is the negative 7. So I add 7 to both sides. On the left side, I'm left with just 9x. On the right side, I'm left with 0. And then the final step I take is to divide both sides by 9. So x is going to equal 0. The reason why I'm divided by 9 is because the 9 and the x are separated by multiplication. The inverse operation is division. The same with the negative 7 up here. The inverse of subtracting 7 or a negative 7 is a positive 7 or adding 7. We could have done this another way. could have instead divided everything by 9, and I would have gotten 1x minus 7/9 equals negative 7/9, and then I could have added 7/9 to both sides, and I will get x equals 0. So I get the same answer either way I complete the problem. We're now ready for number 5. In number 5, I'm working on isolating that r variable. So I'm going to add 5 to both sides. I get positive 1 is equal to, and I'm only left with r divided by 20. The final step that I'm going to take here is I'm going to multiply both sides by 20 because the r is separated from the 20 by division, so the inverse operation is multiplication. On the left side I get 20, on the right side I get 20r divided by 20 when I multiply the numerators and multiply the denominators. 20 divided by 20 is equal to 1, so I get 20 equals 1r, or you could say r is equal to 20. You can switch the order here, so it says r equals 20. Just like I could switch the order at the beginning, here I could write r divided by 20 minus 5 is equal to negative 4. I just switched what was on the left side and what was on the right side, separated by an equal sign. Number 20, all right, so we finished that problem, number 5. Let's go on to number 7. Number 7, this one's new, but again, I'm going to box in the variable and the number that is directly beside it, the one that's closest to it. And then I'm going to get rid of the other number. So the two problem numbers right now are the 9 and the 3. They're keeping the v from being alone. And we want that variable to be isolated. We want it to be alone. So the v plus 9 divided by 3, those two pieces are separated by division, so the inverse operation is multiplication. So I'm going to multiply both sides by 3, and I get 3v plus 9 divided by 3 equals 24. And just notice that I just multiplied the numerator, I multiplied the denominator, just like you would a normal fraction. Then what you'll see here is that the 3 divided by 3 is going to equal 1. And if I multiply 1 times v, I get v, and 1 times 9 is 9. And then the final step I take is I subtract 9 from each side. And on the left side, negative 9 plus 9 is equal to 0, so I get v. And then on the right side, I get 15. So v is equal to 15 is the answer to number 7. We're going to complete 8, so I'm going to go over to the even side. And the first thing we're going to do is we're going to use the distributive property. So I take the 2 on the outside, and I multiply it by the n. And then I take the 2 on the outside, and I multiply it by the 5. So I get 2n plus 10 is equal to negative 2. And then we've seen a problem like this before. I'm going to put a box around the 2n, because I'm going to leave that alone, and I'm going to get rid of the 10 first. We're left with 2n equals negative 12. And then the final step is to use the inverse of multiplication, which is division, and divide each side by 2, and we get n equals negative 6. The next problem we're going to do is number 9. So go back to the odds. Sorry, I was having trouble moving it over. Number 9. So I'm going to box in the negative 9x. I'm going to subtract 1 from each side. On the left side, we get negative 9x, because 1 minus 1 equals 0. On the right side, we get negative 81. Negative 9 and x are separated by multiplication. The inverse operation is division, so we divide each side by negative 9. Whatever you do to one side, you must do to the other to maintain equality. Negative 9 divided by negative 9 is a 1. 1x is the same as just x. And a negative 81 divided by negative 9 is a positive 9, so the final answer is x equals 9. And let's move on to number 11. Number 11. I box in the positive v over 4. The inverse of addition is subtraction, so I subtract 2 from each side because my two problem numbers are 2 and 4. They're both keeping the variable v from being alone on that right side. So I get rid of that negative 2 first. Negative 2 minus 2 is negative 4. 2 minus 2 is 0. That's a 0 pair. It cancels. We're left with v over 4. Then I realize that v is separated from the other problem number by division. The inverse operation is multiplication. When I multiply v over 4 by 4, I automatically just write it as a fraction instead of as an integer in the circled form. You can see where I wrote that because I know that I'm multiplying it by a fraction. On the left side I get negative 16. On the right side I get 4v over 4. I just multiplied the numerators to get the 4v. I multiplied the denominators to get the 4. And 4 divided by 4 equals 1. So I get 1v equals negative 16. So v equals negative 16. We're ready for number 17. Actually, let's do number 12. Go over to number 12, and then we'll go down to number 17. So number 12, it's another problem where we're going to use the distributive property. So the negative 12 is multiplied by Vx. The negative 12 also needs to be multiplied by the positive 5. And then on the other side, I just copy down the 144. So again, I bring down the 144, I bring down the equal sign. Negative 12 times x is negative 12x, and negative 12 times 5 is negative 60. From here, what I'm going to do is I'm going to box in the negative 12x, and then the opposite of a negative 60 is a positive 60. So I add 60 to both sides. On the right side, I'm left with negative 12x. On the left side, I get 204. And then the final step is to divide both sides by negative 12. And on the right side, negative 12 divided by negative 12 is equal to 1. So I get 1x. And then on the left side, 204 divided by negative 12 gives me negative 17. So x equals negative 17. Now we're ready for problem 17. All right, so it's a problem like we saw earlier where we had the variable and a number in the numerator. Again, I'm boxing in the variable and the number that is directly closest to it. It's directly beside it. And then what I'm going to do is I'm going to get rid of the other problem number first. And I have to think about how is the piece that has the variable separated from the problem number. So the piece that has the variable, n plus 5, is separated from the negative 16 by division. So the inverse operation is multiplication. Since I'm multiplying by a fraction, I write it as a fraction. On this side, I don't have to write it as a fraction because I'm just multiplying it by a regular integer. And then on the left side, we get negative 16 times n plus 5. And then in the denominator, we get negative 16. And on the right side, we get a positive 16. Negative 16 divided by negative 16 equals 1. And if you multiply 1 times n plus 5, we just get n plus 5. And then the final step is to subtract 5 from each side. The inverse of addition is subtraction. We have a 0 pair here. And the final answer is n equals 11. And that's going to be it for this video. There's one more video we're going to do on two-step equations before you complete your work.